and eventually find a pathway to the international and the regional competitions. That is the International Math Olympiad, the Pan-African Math Olympiad, and the newly started East African Mathematical Olympiad. The first edition will be on 20th of April this year. We already selected the team from the previous math contest for last year. So the teams for next year will come out of this initiative. So I think that's all I will say for now, and I'm grateful to all of you for attending, and to Semastea and the people from CMC, Honorable Wesley Korir and Professor Ian. So I think that's all I will say for now, and hand over back to Martin.
Thank you very much, Dr. James Katende, for the opening remarks. At this point, I would like to invite Madam Nancy Mui to make one remark from Semastea, and invite the CEO Semastea, who will in turn invite Wesley Korir.
Okay, thank you very much, Martin, the chair of this workshop, the CEO Semastea, facilitators from the University of Waterloo, facilitators from the University of Nairobi, Semastea staff, teachers, the participants, good evening, and all protocols observed. I want to take this opportunity to welcome you all to this training, and observe that as mathematics educators, this is a great opportunity for growth for us. We want to grow in matters, mathematics, and in our interaction in these 2 days, you're actually going to experience that. So I want to wish you well, and I hope we grow and gain as much as possible. At this point, I'm going to invite the CEO Semastea to make her remarks. Welcome, Madam CEO.
Thank you. Thank you very much, Nancy. I'd like to take this opportunity to appreciate all those of you who have been able to organize this particular event. Professor Ian Vanderberg, Honorable Wesley, Dr. James Katende from the University of Nairobi. I really am excited about this. My name is Jacinta Akata. I'm the CEO at Semastea. Martin and the team from Semastea, Madam Nancy Nui, there's a whole team of mathematics department members here that have been working in this program. We are really excited to partner also with CMC and also with the University of Nairobi. And even more exciting is this opportunity to bring teachers together to be able to think through, especially the Olympiads and other activities that are in addition to what we did last year. Mine is to wish you all the best, and knowing that it's going to be quite interesting now that we have even more teachers. And the most valuable thing here is that we are able to scale so that we can be able to reach more students and see how we can excite them through teachers to appreciate the value of maths. Thank you very much and have a good evening. I'd like to take this opportunity to invite the CAS, Ministry of Youth and Sports, Honorable Wesley Korir. Congratulations, Mr. Honorable Korir, for your new appointment. We are really excited about that as well. Welcome to address us.
Thank you so much. Thank you, Madam CEO. Thank you, Martin. Thank you, Nancy. And thank you, everybody, for taking your time to be able to be with us at this training today. My name is Honorable Wesley Korir, as you've been told. For the last couple of years, I've been working with Ian at the University of Waterloo on African initiatives. And I want to say thank you for everybody that have been with us. Some of you joined us last year, and this year we have even bigger team, newer people, and we want to welcome all of you to this event today, but also to the collaboration and partnership that we are about to undertake as teachers, as the university, and also a partnership that we want to do. What are we doing? What we are doing here is bringing our synergy together, bringing the expertise of University of Waterloo and the partnership of the University of Waterloo and Semester and University of Nairobi to make math exciting and make math usable in our lives. All of us are teachers. If you are a teacher out there, the key and everything, the reason why you teach is to impact life. To be able to one day say that I made a difference in one person's life. And we are trying to look at how can we do that through math. For myself, I went to high school in Kenya, and then I went to university in America, and then from America I went to Canada to be able to work in Canada. I worked with the University of Waterloo. My wife is from Canada. I live in Canada. My kids have been going to school in Canada. I've been able to interact with education in Canada, especially mathematics. I came back. I became a member of parliament. I became a leader here. Now I have a unique position as a CAS of youths, but also interacting with other ministries in Kenya. And our goal is, what have we learned from, like myself, what have I learned from all these experience I've gotten from outside this country? I believe we can use mathematics to change a lot of things in Africa and in Kenya. And what we want to introduce now is a problem-solving aspect of mathematics. That's what we want to discuss today is problem solving. All of us want to become problem solvers. Mathematics by itself is a notion of solving problems. So our goal is at CMC with the cooperation of University of Nairobi and Semester is how do we bring problem solving into our mathematics? Even in future, as we move forward, we want to engage teachers and see how we can incorporate problem solving so that we can develop problem solvers. For me, I believe that one thing we are lacking in Africa, in Kenya, as a person, we need to create more problem solvers. More people as young as they are primary school, high school. Let's teach our kids to become problem solvers so that even when they become leaders in future, they can become leaders that can solve problems of this country, problem of Africa. And I think when you look at the developed world, in my experience as I travel around the world as an athlete, as a leader, as I work for University of Waterloo, a lot of these countries have moved from the formula-based mathematics, from the mathematics that we are used to, memorization mathematics, where kids have to memorize mathematics, into a problem-solving mathematics, whereby everything involves, as young as they are 5 years when they get to school, their mathematics is in a way whereby kids are able to solve problems. And I always say, if you can solve a problem of the world, you become a billionaire. The best way to become a billionaire, find a problem in this world and try to solve it. So let's create problem solvers. And this program that we are doing with the University of Waterloo and University of Nairobi is to incorporate problem solving in our mathematics. And last year we started with a contest. The contest was really good. I think some of you here did. And some of the schools did really well. We picked about 4 schools from Kenya that are able to join the CMC contest, international contest that we do. I think some of you have registered and they are going to take part in the contest. Who are CMC? I'll talk a little bit about CMC before I give it back to Ian to continue. CMC is a department of an outreach program through the Department of Mathematics, or the Ian will talk more about CMC, but it's a program that helps kids and make mathematics fun under the University of Waterloo. Part of the things that they do is they have online resources, they have contests they run all over the world every year. They have masters for mathematics, for math teachers. They have all these activities. They have resources that can be useful for mathematics teachers to help mathematics teachers do their job very well. So that's my goal as a colleague with Ian for the last couple of years, as an advisor to Ian for the last couple of years on African Initiative. I welcome you all to this program, and I hope we take part. We get excited. We produce. We identify the best mathematicians. This year, we are moving even further than last year. Last year, we just finished at the contest level. This year, we are picking the team that will represent Kenya in IMO, PAMO, and East African Olympiad. So as your student takes part in this contest this year, we want to pick the best from all over the country. We just don't want to pick kids from Nairobi, from private schools, or from other schools. We want to give every chance to every child in Kenya to be able to take part. And maybe in your school, you know that kid that is very good at mathematics. How can we help them become the best? And also, how can we give them an opportunity to compete with other kids all over the world in mathematics? Let's make mathematics fun. Let's use mathematics to solve our problem by creating more problem solvers in our country. Thank you. Well.
Thank you, Wesley, and good evening. Good morning here from Canada, and good evening to all of you. It is a real joy to be here this evening to talk about mathematics, to talk about problem solving, to talk about our upcoming contests, and to talk about how we can all support education in Kenya, in Canada, internationally. I feel so blessed to be on this journey here of collaboration with Wesley, with our colleagues from the University of Nairobi, with our colleagues from Semastea. And I am learning so much from them and hope that I'm contributing at least a little bit. Here at the CEMC, we are based at a large university in central Canada, where it was about -5 degrees this morning. We are hoping that spring will come someday to central Canada. Not clear that it will at this point. And we are very lucky to be in a place where there's great support for mathematics. We have a large mathematics program here. We have 9,000 undergraduate students studying math at our university. We have 300 faculty members, 300 professors in mathematics here. And so we are, as a result, have the opportunity and the capability of doing so much. And we want to be partners in many, many places around the world. So it's a joy to be here. I'm going to send things back to Martin for a little bit, I think, and then I'll look forward to talking more directly about problem solving and about contest kinds of things shortly. Martin, I'm going to send it back to you to see if you have other things you want to talk through right now.
Ian, I think Martin is gone, but I think from what I think now, Ian, you can take over.
All right.
And run it from your side.
There's Martin. Martin just it's right there. Martin, do you want to say anything at this point?
Just wanted to remind the participants that we will share the registration link towards the end of the session. Thank you.
Thank you, Martin. So I'm going to share my screen here. I'm going to from over on this side of my office. Hope that this works. So my goal over the next hour or so is to talk about problem solving in general, to talk about how problem solving fits in with mathematics, how we might talk about problem solving in mathematics, and to talk about contests specifically. As Wesley and I have talked about, we are really lucky here at the CEMC to have a large team of people who are invested in mathematics education, like all of you who are taking the time to be here this evening. Our mission at the CEMC, I think, aligns really well with what what we as a group of 3 partners are trying to do through these contest opportunities. We are all trying to increase the interest, increase enjoyment, increase confidence, and increase ability in mathematics among young people and among you as educators. Mathematics is a discipline that is at the forefront of everything that we do in this world. And building capacity in mathematics among our young people, building the ability to think in mathematics and think outside of mathematics among our young people is such an important part of what we do as educators. Teachers in our world are what make everything else possible. Teachers make every other profession possible through the work that you do with young people. And the great work that SEMASTEA does in training and providing opportunities to you, the great work University of Nairobi does in building these connections, this is what makes the world go round. The young people that are going to be those leaders that are going to come through our classrooms, that we are going to touch and influence. And if we can help them learn to think critically, if we can help them learn to love to learn, these things are going to pay off for us as a global society in ways like we've never seen before. In the last 3 years, we've been through lots of bumps along the way, with COVID, with the war in Ukraine, with all sorts of other things going on right now in our world. And education is, for me, probably the most important thing that we're doing in our world, and something that sometimes gets overlooked, and the importance of it gets overlooked. So the fact that we are here and ready to engage in this is so important. Part of what we are hoping here, and Nancy referred to this a little bit earlier, is to cause growth in our students, to cause growth in the kinds of things that they can do, the kinds of challenges that they can tackle. And for us as educators, that growth hopefully comes for us too, to be able to then inspire those teachers that we're going to work with. So I want to talk first of all about mathematical problem solving. And then as Wesley has so cogently shared his vision for problem solving and how problem solving affects our world, I want to sort of talk about how all of that works together, and then we'll dive into doing some mathematical problem solving and talk about contest kind of things. So these, I think, are questions that I want to ask myself as an educator. And as I'm teaching, I'm actually teaching teachers right now about problem solving. That's the course I'm teaching through our university right at this very minute. What are the most important parts of mathematics? Why do we teach mathematics? And what do we want students to take away from mathematics? This happens sometimes that my Wi-Fi connection here dies, so I'm going to work on resurrecting this while I talk. I think for me, mathematics is a discipline that has many things at a high level, and has many things at many different levels that we teach. In the mathematics classroom, we teach many really specific things. We teach algebraic skills. We teach geometrical concepts. We teach different ways of approaching questions and exercises. And through those very specific things that we teach, how to solve a quadratic equation, how to use the sine law, how to use the Pythagorean theorem, trigonometry, calculus, vectors, all of those important things that we teach, as we teach those things, we are at the same time training our students' minds. We are training them to think. And it is, for me, those thinking skills that are the most important skills of all. It is those thinking skills that we really want our students to come away from mathematics with. I'm going to reshare my screen here on my other screen and see if this works better. There. So here for me is one way of looking at mathematics education, of looking at this as a place where we start in mathematics education by teaching skills. But through these skills, we are trying to teach some really high-level thinking kinds of things. We're trying to teach analytical, logical, and systematic thinking. We're trying to teach creative thinking. We're trying to teach visualization. We're trying to teach communication and the ability to abstract. So behind all of the specifics we teach in mathematics, these are the five, for me, the five biggest thinking parts that we're trying to do. And we don't go into the classroom, I don't go into the classroom and say, today I want to teach my students to visualize. No, I'm going into the classroom really trying to teach specific things, and through those, helping them to learn these other skills. And once they've learned these thinking skills, these five big thinking skills in the middle, they can then move on to applications. They can then go on to apply these things to the real world. They can go on to be able to solve real world problems, to make vaccines, to try to come up with ways of doing carbon capture, to think about agriculture, to think about all of these really important things. And once we've taught our students that, we're setting them up to become leaders. We're setting them up to become our great thinkers and the ones who are going to innovate. In the mathematics classroom, we do this, in my opinion, differently than every other subject. Now, I will admit I have a bias. I'm a mathematician. I love math. I want my students to love math. I want my students to see the relevance of math to the world. But with those connections, with those thinking skills, students are going to be able to go out and do these. When we need a problem solved in our world, we want students who can think mathematically. One of the things that we talk about here in our mathematics programs, as I said, we have many thousands of students in mathematics. What is it that students can do once they've studied math at the secondary level or at the post-secondary level? What can they do with it? And we say, I think correctly, that students can do anything they want with it. If you want to hire somebody who can do a job for you, and you need them to be able to think, hire somebody who knows math. And people worldwide have realized this when they're trying to hire people. They hire people with math backgrounds. Problem solving in our world, as I mentioned, I think is really important. Whether this is in Canada, whether this is in Kenya, whether this is in other parts of the world, we want people to be able to think about problem solving. We want people to realize that problem solving, thinking about problem solving, is going to lead to progress. Progress is a slightly dangerous word, I recognize, but it's going to lead to better ability to think, better ability to cope with the challenges ahead. When I was in Kenya in November, this is my second time to Kenya. I had been to Kenya many, many years ago. It was wonderful to be back. I got to learn so much from my colleagues at Semastea, University of Nairobi, from teachers I met with. One of the teachers we met with said something really important, and this has stuck with me. We want students to be able to solve tomorrow's problems. We want students to be able to solve tomorrow's problems. But we can only really teach them at this point to solve today's problems. But we need to be able to teach them to think in such a way that they will be able to solve tomorrow's problems. And that's really, at this point, I think, our goal. I want to talk about problem solving in mathematics. And I think problem solving in mathematics is something that everybody can do. Every child, every student has the ability to learn to think this way. And it is a way of thinking, and it's an approach to the mathematical world that I think is really important. And it's something that we need to train. We can't just imagine that it's going to happen. We can't just hope it happens. We have to do it relatively intentional. And one of the things that Wesley and I and colleagues have been talking about is how to find ways of incorporating this more into our already busy teaching lives. That's a conversation for another day. But what is a problem in mathematics? What does problem solving mean? Well, for me, a problem is something that's less direct than an exercise. An exercise might be, take what I've just taught you, and in 2 or 3 steps, apply something, move on from that point. A problem is something that's less direct than that. It's something that may take several steps along the way. It may take going in a different direction than you think. Maybe it's going to combine multiple ideas or multiple areas of mathematics. Problem solving doesn't necessarily involve word problem. Doesn't necessarily involve context. And there's lots of conversation in mathematics education about the inclusion of context in problems. And I'm somebody who lies kind of in the middle on this. That some problems work really well when we build a real-world context about it. Wesley is, let's say hypothetically, Wesley is running around a track and add some context to that. But maybe the same problem with just the math is okay. So I think there are lots of different ways of thinking about this. And I think everybody's going to approach this in their own way. And you as educators need to think about this. I think that it is important for students to be able to solve problems. They need some background in mathematics already. They need some skills. They need some number sense. And in my experience, limited, much more limited than all of yours, in observing teachers and students in Kenya, students and teachers in Kenya seem to do this really well. They have a great grasp of fundamental concepts, and that's wonderful. And that's something, in my opinion, that we're actually lacking a little bit in our Canadian mathematics education system. Is a bit, sometimes we have a little too little of a focus on skills and on foundational concepts. And I think we're moving back into the middle on this. It's also important for problem solving that students need to be able to recognize patterns. And patterns at a whole bunch of different levels. Some of them is just recognizing a pattern within a problem. Oh, and we'll see this in a minute when we dive into a couple of problems. But some of this is also pattern recognition at a much higher cognitive level, where we're trying to connect this problem we're working on now to that problem we worked on before. Students who get into problem solving, who get into things like contests or competitions or challenges of various kinds in mathematics, and there are so many of these that exist in our world. Students who get into this are exceptionally good at this part. At being able to find a problem and say, well, that's like the one we did last week. I'm going to use that technique here. This is, I think, one of the most powerful things we can do as problem solvers, all of us. Recognizing patterns in our world, recognizing patterns in our learning, recognizing patterns in the mathematics that we're being taught and we're doing. It's also really important to have patience, to be humble, to learn, to be ready to learn from our mistakes and to persevere. These, I think, are important and challenging kinds of mental things that we sometimes don't really recognize come with the mathematics classroom. We live in a world in 2023 where we expect to be able to do everything really quickly. Where we will, if the video is longer than 30 seconds, we're not going to watch it. If it's going to take me more than a minute to understand this idea, I'm not interested. But the world doesn't work this way. We have challenges in our world that are going to take days and months and years and decades to solve. We need people who are going to persevere through this. We need to teach our students about this by presenting them with these challenges. Some students are challenged by the curriculum that we teach, And it's important to help them learn that. Some students aren't challenged by the curriculum that we teach. And those students we owe the challenge to as well. We need to be able to find things to challenge them. And the problem-solving kinds of things that we're going to talk about, I think will really help some students down that path. Teaching and promoting problem solving. This is an important thing to think about. This is outside of the scope of what we're talking about here. And maybe this is a topic for another day, but I know that many teachers, this is something here in our Canadian context that we are encouraging teachers to incorporate regularly in their classrooms. To focus on teaching problem-solving strategies. To focus on giving students a toolbox for problem solving. And our hope is that through these contest activities, that there will be opportunities for teachers, for students, to engage with those kinds of things. And also to encourage risk-taking and trying things, to trying different approaches. I know that as students mature, as they go along through their academic progression, we find here that students sometimes start to lose the interest in taking a risk. They're much more willing to take a risk by answering a question that they're not really sure about when they're 13 than when they're 17. And problem solving, I hope, is something that will continue to try to support this kind of idea. So, I would like to dive into actually looking at 2 or 3 problems over the next little while here. And I'm going to present these problems and encourage you to think about them, and then talk about a couple of different ways of solving them, in at least a couple of the cases. So here's the first problem, and this is a problem that appeared last year on our contest, on our joint contest with Semastea. This is a kind of problem. It's mathematical thinking. There's mathematics in the problem, but it might look a little bit different from a traditional mathematics question. So here's the question. There are 9 people in a room. Each one of them must shake hands with everybody else once. How many handshakes will there be in total? This is the problem that we'd like to try to solve. So I'm going to give you a minute or two to think about this problem and see if you can think about an approach. See if you can think about an answer. If you come up with an approach and an answer, maybe you can come up with a second approach. I'm going to ask you for the time being please don't type the answer. If you have an answer, please don't type it in the chat, because we want to give others a chance to think about this. Take a minute or two and see if you can come up with an approach to this. I think there are people who are able to write on the screen here somehow. I'm not sure how that happened. And so I'm going to try to disable that right now. So I'll give you a couple of minutes to think. I'm going to start up my technology, and we will talk about this question shortly. All right, let's talk about this problem. There have been lots of people who put ideas in the chat, answers and approaches. So let's talk about how this could work. And first of all, before we get to an answer, I want to emphasize that for me, it's not so much the answer that's important here, but it's the thinking. It's the process of getting to that answer. And that's, I think, a really crucial part of mathematics that we sometimes overlook, and students often overlook this, certainly. They want to get the answer. They want to get past that finish line. They don't care so much about how they got there. But it's the getting there, it's the thinking that is actually going to be what we really want to emphasize. And yes, on a contest, it is to a certain point about getting the right answer, sure. But it's the journey along the way to get there. It's a journey of preparing and thinking. It's a journey about talking after the fact about it. So let's set some of the context here to see about what this might really mean. There are 9 people. They're going to shake hands with everybody else once. So one question, just for clarification, and to partially to start this out, is if we had 2 people, if there were 2 people, I'm hoping that I'm writing here. It's writing in the one place. It's not showing up in the other place yet. Let's hope that this is going to work. It's not. Okay, so we're going to switch to a different approach here. Just give me a minute to do a switch on this again. It's obviously not going to work. We're going to go over here, share screen, continue. Technology. As we all know from the last several years, technology is great sometimes and awful lots of the other times. So, we have 9 people in a room. Each of them must shake hands with everybody else once. The first question I want to make sure that we understand is what happens when there is a small number of people? If there are 2 people, if there are just 2 people in the room, how many handshakes would there be? If there are just 2 people, how many handshakes would there be? So if you have an answer to that question, why don't you put it in the chat, please? One. Yes, lots of ones here. Thank you. If there are 2 people, there's only going to be 1 handshake. And I'm going to work on writing on the screen here in a second. If there are 2 people, there's just 1 handshake. How about if there are 3 people? If there are 3 people, how many handshakes would there be? there would be, oh, there are 3 people. There are going to be 3 handshakes, I think. So if there are 3 people, then A, let's call them A, B, and C. A is going to shake hands with B. A is going to shake hands with C. And B is going to shake hands with C. So there are 3 handshakes. With 3 people, there are 3 handshakes. I'm going to put a note here that maybe you can see. So with 2 people equals 1 handshake. 3 people equals 3 handshakes. So that's the first thing we want to talk about. Make sure we understand kind of how this works. So what happens then with 9 people? One way to think about this is to think about, to label these people perhaps A through I. Person A I'm going to try to do this. Sorry, I have an iPad here which has decided to die and not connect to the internet right at this very minute. I'm going to try to connect this again because if I can, it's way easier to write on the screen than for me to try to figure out how to type on the screen here. So I apologize for the technology issues. And we'll see one more try here. If we can get this to work. Okay, well, it tells me it's working right now. So we're going to say a quick prayer to the technology part. No audio. The co-host. Share content. Screen. Start broadcast. Okay, there we go. So 2 people we said was 1 handshake. With 3 people, there were 3 handshakes. So let's think about this now with 9 people. With 9 people. So the first person with 9 people, A, let's call the first person A. A shakes hands with 8 people. A kind of goes through the room. Perhaps pretend they're Wesley Career going around a room and shaking hands with people. A goes through and shakes hands with 8 people. Everybody else who's in the room. B, who's the next person, how many hands does B now shake?
What?
Mr. Omar, I've been knocking.
What? On a serious note?
I've been knocking almost 5 times.
Seriously?
Serious? Ninashangaa mtu kwani ameenda ni.
What?
I've been asleep.
I've been asleep, bro. Wait. Where's Mr. Mango?
No.
I was in a meeting.
Ah.
And then all of a sudden, slept.
Na Mr. Omar tukifunga tunaruhusu vijana wengine.
Definitely.
Kwanza saa ngapi?
Kuanzia saa 2 mpaka saa 11:30.
Jioni.
Yeah. Lakini mtakuwa mnapewa pesa ya lunch na wazazi wenu. Si tricky. Imagine you're just sacrificing for only those 16 days, then the other incoming holiday. Yeah. It's worth it. If other students have been attending, Kasera has been attending.
Looks like 6 and 8 are both popular answers coming through in the chat. Great that people are thinking about this and trying this. Thank you.
Sasa, ujitayarishe, prepare your mindset, eh?
Let's see if we can come up with a way of doing this. One way, of course, is to try to trace the roots. I can go 1 that way, up and down that way, and try to work through this. And that works reasonably well for a map of this size. If the map was even a little bit bigger, that would be really awkward to do that. I don't know about you, but I have trouble keeping track of these kinds of things, I will admit. So I want to think about a slightly different way of doing this. And that's to work from left to right through the diagram and try to label something sensible. So I'm going to look at each of these, what I'm going to call vertices, places where the lines intersect. I'm going to ask, first of all, at this one and that one, how many roots are there to those vertices? Well, there's just one to each of those. This is going part way along the map. There's only one way to get there, either to go up to the top one. If we were looking at the bottom one, we go down. Let's now try the one in the middle. How many roots are there to get to this middle one? And the answer is 3. Either we go directly from Nairobi to that middle one, we go up and then down, or we go down and then up. There are 3 ways to get there. Well, how about this one? Top right. How many ways to get to the top right? In fact, to get to the top right, there are 1 plus 3 ways. Because to get to that top right, either we're going through this top one, or we're going through the middle one. We have to come from one place or the other. So to get to that top right, either I'm starting off by going to the 1, or I'm going through the 3. It has to come from one of those 2 places. Could have gone through the 1 to get to the 3, but we're not. But that's included in the 3. So this number up here is 4. 1 plus 3. Similarly, down there on the bottom in the middle, that's going to be 3 plus 1. 3 plus 1. Which means at Nakuru, the total number is 8. Total at Nakuru, the total number is 8. as I've traced through my map. This is a great method for counting roots in other kinds of contexts. If I had a grid and I wanted to go from bottom left to the top right, and I wanted to go right and up only, wanted to count the number of roots along here, this is a method I could use. I could count at each point. There's one root to that point, and one root to that point, and two to the one in the middle. One across, either across and up, or go up and across. And continue out through my grid to get to the end. This is, again, problem solving. It's not using a formula. Some students, I find the students that I teach can be really formula driven. Sir, can you give me a formula to answer this? Well, I could, but then you don't think about it. You don't actually understand. You're just trying to apply a formula. Nothing wrong with that. But if he can help start to move students a little bit from the formula, give me a formula, to the, how would I think about this? This is important. A problem like this has a tremendous real-world impact. You might be Air Kenya. You might be FedEx. You might be busing students to schools. You might be delivering the mail. You might be picking up milk from farmers. How can I find the number of routes? How can I find the shortest route? How can I use the least gas? How can I make sure the driver is on the road for the least time? How can I make sure the person walking with the mail has to walk the least distance? These are real-world problems with important implications to people, with important implications to greenhouse gas kinds of things, to climate change. These are all important kinds of things that we need to think about. Mathematics does impact our real world in those kinds of ways. This problem here is not so much a real world problem. It's not one that FedEx is going to want the answer to right now. But the thinking is what we want to develop. Here is a problem in a different context. This is also, to my mind, problem solving. But it doesn't involve roots, and it doesn't involve handshakes, doesn't involve a context so much. It involves an equation. And this, I think, is still where thinking comes in. Mathematics and our approach to mathematics, in my opinion, has to always be about thinking, but doing something a little bit unusual. For my students here, this would be an unusual looking equation that they would see. Yes, they can solve equations with logarithms in it. They're used to that. But not so much equations where the logarithm is in a different place than they expect. Here is a place where students have to be willing to try something, to take a risk. To me, a natural thing to try in this problem is to try to get the logarithm out of the exponent. How can I get something out of an exponent? One way to do that is to take the logarithm of two sides of an equation, because then logarithm rules allow me to pull the logarithm out of the exponent. If this was unfamiliar to a student, if this look of an equation, then this is a kind of next step kind of thing. So let's try taking the logarithm base 2 of both sides. Logarithms are concepts that students learn later on. That's okay. Sometimes we need more advanced mathematics content. The previous couple of problems could be thought about by students who were in primary school. This one, not so much. So I've taken the logarithm base 2 of both sides. The right side is 8. Log base 2 of 256 is 8. Now, I'm going to apply a logarithm rule. So I'm going to have 2 times the log base 2 of x. That's my exponent. Times the log base 2 of x equals 8. So this actually now gives me that the log base 2 of x all squared is 4. With a factor of 2 on the left side, I'm going to divide that, and I'm going to pull my 2 logs in the product together. This is the point where students would be tempted to write the log base 2 of x squared and put the exponent back in, breaking logarithm rules left, right, and center. This tells me then that the log base 2 of x is plus or minus 2. And because x is an integer, x equals 4, not a quarter. And that's what John had suggested in the chat. Very good. Is this problem solving? I would argue it is. It's doing something in a slightly non-traditional way, requiring students to think about an approach that might not be an approach that they're used to doing. For some of you, this problem, this question, you might say, no, my students can actually handle this easily. They're used to this kind of question. And this is where some of the perspective comes into problem solving. That sometimes something that you might think is an exercise, I might think is a problem, and vice versa. That's okay. It creates conversation. It generates thinking. And that's a really important point. So problem solving is like this. It's this idea of thinking outside the box, of trying something new and unusual. I'm not going to go through this problem specifically, but this is a different kind of problem. And we'll make sure that we share these slides through the WhatsApp group afterwards. I will post this there so you can have these. This is a problem involving parabolas, involving quadratic equations. And it defines something of a rectangle with its vertices, 2 vertices on a specific parabola, and 2 vertices on the axes. We call this in the question a parabolic rectangle. And then there are several parts to a question. One where it gives us a vertex and asks for the other 3. One where it gives us a vertex and it asks for the area of the rectangle. One where it gives us the area and asks us for the vertices. And one that asks something slightly different. I really like this kind of problem here because it leads students through thinking ideas. It introduces a concept, takes a concept they're familiar with, a parabola, another concept, rectangles, and puts these together. And asks students to think through this kind of idea. To learn about something, to read a definition, to try to understand what that means and then to apply it. problems that are successively a little bit more challenging as you go through the various parts here. And problems that hopefully lead students to setting up an approach as they go on. The first three problems that we looked at are the kinds of problems that might appear on round one of this year's Kenya Mathematics Olympiad that we are collectively putting together with SEMASTEA, with University of Nairobi, and hopefully with your help too in assembling the problems for this. These are the kinds of styles of questions that we might ask and the kind of level. The third one being on the harder end, the first two being kind of in the middle in terms of level of difficulty. But it's those kinds of questions that we want students to think about. And I believe students from all backgrounds in mathematics have a great chance to think about these and to learn about these and to try to digest them and to get something out of it. So, why contests? Why are contests something that students might want to participate in? It's something that teachers might want to encourage their students to be involved in. Something that we as people who create these, why do we do this? I think for me, contests are a way of pulling mathematics out of the classroom and getting students to think about it in a slightly different context. I've likened this in my conversations with Wesley to ideas around sports. Not all of us is into sports. Not all of us have world-leading athletic records like Wesley do. But we all have a sense of what this means, that students participate in games. They might be on a team that does well at something, that competes. Math can be the same. Sports, I think we see as fun. Math can be the same. Sports, we can see students going to the next level and the next level and the next level. Math can be the same. And I think this is an important kind of mindset around this. I think that contests can help inspire students to take math a little bit further, to look at it in a different light. For sometimes, for students who are easily handling the curriculum that we're teaching them, maybe a contest asks them to think in a different way than we've tried before. Maybe a contest asks them something a little bit harder than they've seen before. And they try that and they overcome the challenge and they solve it. And that's brilliant when that happens. What should students expect? I think that it's really important when you have students writing this contest in May, that students know what they're going to expect. They know the kinds of questions they're going to see. And we'll certainly share with you, I will share with you in the WhatsApp group, the contest that we set last year, which will be equivalent to the round one that we're setting this year. You can see the kinds of styles, and students could see this ahead of time. I always say to teachers here in Canada who might be having students write a contest, it's really important that students know that this isn't a test. We're not judging them on how they do. We're encouraging them to try their best. We're encouraging them to take some risks. Students might expect, a good student writing a contest might expect to get between half and 2/3 of the questions correct, which might be different than their normal classroom experience and important to help students set those kinds of expectations. For them to understand that difference, that it's not about trying to get 90% of the questions right. If they do, brilliant. But that may not be quite where they're at, and that's okay. How far can students go? James and Wesley and others have mentioned this earlier on about the process that's going to unfold over a number of months. Like with athletics, we can think about contests that happen, sports meets that happen, running that happens at a school level, and then at a regional level, and then at a national level, and then at an international level. Math is the same kind of thing. We are this year going to be running a sequence of these events. Round 1 that will be in May is for everybody to participate in at the school level, and Semastea will have lots of great support and details for you about how this is going to work. And we encourage you to involve lots of students who are interested in math and want to try a challenge like this. From that set of students who write at the school level, a subset will be chosen who've done particularly well in that first round to write the second round that'll happen later in the year, where the questions will be a little bit harder. They'll have a little longer to do it. The first contest will be about 25 questions. It'll be about an hour long. Second contest will be 20 questions and 2 hours long. Fewer questions, more time. Students who do well in that second round then are going to go on to a third round, where the questions go from being answers only to students having to communicate, to write a solution. And the questions get more challenging. The students who move on through this eventually perhaps might be invited to represent Kenya at an international level through something like the Pan-African Mathematics Olympiad or the International Mathematics Olympiad. These are amazing opportunities for young people. It's amazing for them to be able to meet other young people like them, other students from across the continent, across the country, across the continent, around the world, who have an interest and an aptitude in maths and can be inspired by those kinds of connections. In all of this, there's a balance between curriculum and problem solving. The best problem-solving questions, in my opinion, are ones that don't use a lot of mathematical content. You don't need to know calculus. You don't need to know really advanced formulas in trigonometry. But that you can think your way through it. Maybe you need some number theory knowledge. Maybe you need some geometry knowledge. But basic curriculum develops these skills. So we are trying to balance curriculum and problem solving. In tomorrow's session, 2 of my colleagues, Jeff and Sandy from the University of Waterloo, from our CEMC here, are going to walk you through a workshop on creating problems, on how to take ideas and how to generate questions that might appear in a contest like this. This is a really important and really interesting exercise, I think, because it makes you, I think they're going to challenge you to think perhaps in ways you haven't thought before about setting questions, about how to assess questions, about how to create good multiple choice answers. So they're going to give you lots of great insight for this, and there will be a different Zoom link for tomorrow's meeting that will get posted in WhatsApp after this meeting today. So you'll be able to access that tomorrow. For outcomes from contests, what positive things come out of this? Students having fun with mathematics. Students recognizing other mathematics who excelled at this.
If you want to leave, I can
Students
just
having
move
the
out.
opportunity to move on, to meet students from other parts of the country.
Huh?
Students feeling great about
Hey,
themselves, about what
You
they've
can
done,
push me.
which means that we need to set them up for that success
I can't.
by helping them
18%
understand what success might look like.
itanisustain. Ikishindwa kunisustain, don't worry, I'm still in my school. I can go to any office.
I will share with you after our session today in the chat. I'm going to share with you
That's okay.
last year's contest. I'll put this
That's
in the
okay.
WhatsApp group that you can download from there. You can look at the questions. You can see the kinds of style like the ones we've talked about before.
That's okay.
You can see what the contest looks like. And that's an important kind of thing to do, to share with students who are going to write it. When you have students going to write this, for them to be able to spend some time trying some of last year's questions is a great way for them to think about this year's contest, so they know what it looks like. I want to share with you briefly a couple of what I'm going to call next level questions. And these are the kinds of questions that we might see later in round 2 and round 3 and beyond. So that we have a sense of what this could look like. This is a question that we asked here in Canada on a contest that we had students write in November. We have here about 260,000 students who write our contests every year.
Sessions.
We have
Hapo hapo
tens
inaingia
of
class.
students participating from a variety of schools in a variety of places, and we are really fortunate to be able to connect with so many schools and teachers. This is a question that appeared on a contest that we had for Form 3 and Form 4 students. We call that grade 9 and grade 10 here in Canada. How many ways are there to choose integers A, B, and C from this list? So that the product is a multiple of 12. To solve this problem was actually pretty intricate. You had to think about factors of 2 and factors of 3, try to figure out where they come from, try to deal with overlap questions, and there was a lot that you had to do to solve this problem. But students can do this. Students love the challenge, and they're going to dive right into it. I also wanted to share with you a sample PAMO problem. So this is from the 2022 Pan-African Mathematics Olympiad. This is for students who are really excelling, who've shown an aptitude, shown an interest, and then been trained by our colleagues like Professor James Katende and others, trained to take the math that they know and then add some of this on. Like, again, back to the example of training for national or international athletic events. Interest is great and will help you succeed. Talent is great and will help you succeed. But then you need training to be able to do the hard things, to be able to run the 42 kilometers, to be able to do the high jump, to do those things. The same in math. Find all triples ABC of positive integers with A greater than or equal to B greater than or equal to C, for which these three
This
expressions,
is very important.
A squared plus 3B, B squared plus 3C,
Kabisa.
and C squared plus 3A
I allow
are all perfect squares.
Sasa.
At PAMO,
Pamoja kabisa.
first round,
Pleasure.
let's start back. First round, 60 minutes, 25 questions. PAMO, 4.5 hours,
Ba.
3 questions.
Hata ni meeting hii hata.
4.5 hours,
Yeah,
3 questions. These
Pan-African Maths
questions are
Olympiad.
intricate. They're hard. They take a couple of hours if you're even able to solve them. I can tell you for sure that 1, 1, 1 is the solution to this problem. If A is 1, B is 1, and C is 1, I get 4, 4, and 4. I don't know whether there are other solutions or not. I haven't really tried this question. I think it looks kind of interesting to me, and I'd like to play around with it at some point, but I haven't really tried it yet. But this is a kind of problem that students can try, students who want to engage with this and to sit on a question for a long period of time, to work with great trainers like James and his colleagues, to work with our great friends at Semastea, to try to improve themselves, to try to move along. I want to leave you. I'm going to spend a couple more minutes and then turn things back over to Martin, who will have some other things to share with us. I think Martin or Nancy or other colleagues here. As you were thinking about contests, Jeff and Sandy might talk more about this tomorrow. Advice for students. And I think all of this applies to contests at a variety of levels. Are we trying to solve problems or get answers? We sometimes get into this mindset that we just want the answer. We talked about this a little bit earlier. That's what students want. Just tell me the answer and I'm going to go on to the next question. Well, no, let's slow down and talk about the journey, talk about the solution, talk about solving the problem. I would say in a contest, we have to balance this. Contests for students who are trying to do well, they need to get answers. and they're going to try to get an answer and move on to the next question because they want to solve a lot of the questions. But we also want to solve the problem. And maybe some of that happens afterwards. At the contest time, you're getting an answer, but afterwards we stop and we work together, teachers and students and university people and SEMASTEA, and talk about how would we actually solve these questions? What's the thinking behind it? Why is this important? A second tip is to avoid random guessing. It's very tempting when there's multiple choice. If you don't know the answer, guess. In this case, in our contest last year, you got points for leaving questions blank. In other words, if you got it wrong, you got 0 for that question. But if you left it blank, you would get a couple of points. There are philosophical arguments for and against this. I like this because it encourages students to really understand whether they know how to do the question or not. If they're not sure, leave it blank. If they're sure, answer it. I think this is an important life skill. Important life skill to know whether or not you really think you know the answer. If you don't, then back off from it. Move on to the next question. Time management is also an important part of going through contests like this. Is using your time effectively to get to the end, to give yourself as much time as you can. Don't get too bogged down on a question along the way. If you're not sure, think about it, move on. Your brain will keep thinking about it. Students' brains will think about this while they've moved on to another question. Then come back at the end. These, I think, are important things to think about, important pieces of advice that I would encourage you to give to your students eventually around this. Maybe these are applicable in a broader context outside of this contest. And I would encourage you to think about that too. Tomorrow, as we mentioned, Jeff and Sandy from CEMC will be here to talk about problem creation, walk you through that. And that's, I think, a really interesting session, and one that I hope you will find applicable as much to your own classroom teaching as you will to this exercise of thinking about contests and helping to create contests that are here. In the end, what is all of this about? In the end, this is all about inspiring young people to engage with mathematics. Because mathematics opens doors. Mathematics opens doors to the world in so many different ways. It encourages students to think. It sets them up for being our problem solvers in the future, overcoming today's problems and tomorrow's problems. Our hope collectively, CEMC, SEMASTEA, University of Nairobi, is that through these activities, we are engaging students, helping you as mathematics educators engage your students differently, helping to inspire them to go on to other things, to push themselves academically. These are great opportunities. I was lucky enough as a high school student many decades ago to be a student who got engaged with contests and found this so exciting and something that I really wanted to pursue. And it was what led me through my career, through my journey in mathematics. And my hope is that there will be students like me, like you, who get inspired along the way for that. Thank you for letting me talk with you for a while. Thank you for thinking this morning. I'm going to turn things back to Martin and colleagues here, and then we can, if I need to jump back in a little bit later, I can, if there are other things I need to contribute, but I'm going to welcome Martin back here now.
Thank you, Prof. Thank you very much. I think that was quite informative. And colleague teachers, I think you agree with me that Prof is cut out for problem solving and has taken us through in very detailed and systematic manner on how to go about in problem solving. I really can't wait for tomorrow's sessions where we'll be able to look at problem creation, as Prof has said, and then we will have the skills and the knowledge that will help us be able to support our learners and our students in problem solving and in preparation for the contest that is coming. As I said at the beginning, ultimately, somebody is talking. Ultimately, yes, ultimately, what we hope is that the successful students after the contest will be able to prepare for both the PAMO and the IMO. So thank you very much, Prof. Dear colleagues, there is the registration link that we have provided. And I have said that please don't register by putting your name on the chat because it will be recorded as absent. Kindly use the link provided so that we will be able to keep tab on the people who have been able to stay in the session, and that is good enough for accountability purposes and also for transparency. So kindly use the link. It is provided. Somebody is asking where is the link. It has been on the chat for the last couple of minutes and I have resent over and again. So kindly use that to register and just have your name captured, as I said, for purposes of accountability. Somebody is saying, kindly send again. It is there on the chat. It is on the chat. If you go to the chat, you'll see that link. But we'll still be able to send again because we need your details captured in there. So I think, I don't know, Honorable Wesley, do you have anything to add? Then we conclude. Honorable Wesley?
Yeah, thanks, Martin. Thanks, Ian, again for this wonderful session. I hope teachers you are able to enjoy and learn something. And I think we will continue. This is just a start. We look forward to, with the help of Semester and the help of you teachers, to be doing what we call online school visits, like Zoom school visits, so that what Ian has done to you teachers, he can do it also with the students. So we'll hope that when that time comes, we will be able to be sharing the link at your at the group that you joined today. And I hope you teachers will help us make and help your students join the Zoom link so that Ian can take them through such questions and help the students just practice some of these problem solving as they prepare for the contest. So we look forward to continuing this interaction and helping our students become critical thinkers and problem solvers. Thank you so much, and God bless you, and have a good night. See you tomorrow.
Thank you very much, Honorable Wesley. Maybe
Thank you very much. Good night, too.
Closing out for us with a word of prayer. Let's say the grace together.
Thank you very much. Good night, too.
We have somebody closing the word of prayer.
May the grace of our Lord Jesus Christ, yes, and we pray.
One prayer.
Amen.
Amen. Thank you very much. Thank you.
That was very short.
Amen.
Thank you, everybody.
Register. Please register so that your name doesn't
Amen.
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 Good night.
Good presentation. Bados.
Record.